So today we're going to review probability. This first problem we're going to do is problem 50, and I've actually just written down the essential information, but feel free to follow along in your book. Feel free to stop the video at any time and read the problem over. In this problem, we're looking at Sky's ice cream shop, and Mario is getting to choose his favorite ice cream. The first part asks us that we have to create a table or make a list of all his possible combinations. And so I decided I wrote down the types of cones or the types of sundaes he can have, and I wrote down the different types of ice cream. What we're going to do next is we're going to make a table. I wrote the two types. He could have a waffle cone or he could have a sundae. And here are the three types of ice cream. So what his options are, he could have apricot on a waffle cone, so waffle cone apricot. He could have chocolate on a waffle cone. He could have blackberry on a waffle cone. Or he could have it in a sundae in a cup. So he could have sundae apricot, sundae chocolate, and sundae blackberry. So what this tells me, this table right here, is that I have 6 possibilities altogether. Part of the problem asks, what is the probability that Mario will get something with apricot ice cream? Well, we're going to look for all the chances that we have A. So we have 1 right there, and we have 1 right there. So for part B, the probability is 2/6, which is simplified to 1/3 because he has 2 apricot options out of 6 total. So he has 1/3 of chance of getting something with apricot. Part C is what is the probability that he will get a sundae? Well, if we look at our probability for sundae, we have sundaes, sundae, and sundae. So for part C, we're looking at 3/6 or 1/2 is his chance that he will get a sundae. Part D asks, what is the probability that he will either get something with chocolate or a waffle cone with blackberry? So we're going to look at our chances of getting something with chocolate, and we're going to add that to our chances of getting something on with the cone and the blackberry. So I'm going to erase these so it makes it a little easier to track. And our first thing we need to look at are what are his chances of getting chocolate. So we have chocolate right here and chocolate right there. That is 2/6 chance. All right? So I'm going to write that actually over here. This is part C. So 2/6, which equals 1/3, and that's his chocolate. Then we need to look at his chances of getting a waffle cone with blackberry. There's our waffle cone, and blackberry, that's 1 out of 6. So 1/6 is the blackberry. And then we're going to add those together. We can use a common denominator. 1/3 plus 1/6 is going to be simplified to 1/2. So those are your chances of getting either one of those options. All right. And then finally it says part E, what is the probability that he will get orange sherbet? Well, he doesn't even have orange sherbet, so his chances are a big egg. It's 0. All right, I'll be back with another problem about probability. So we're still reviewing probability, and this problem is problem 88. So follow along in your book so you know what we're talking about. So for this one, it says Lucas is having yogurt and an apple for snack, and we need to find the probability for different questions. So I wrote down all the information we know in our problem. We have 3 raspberry yogurts, we have 1 vanilla yogurt, and we have 1 peach yogurt, which means altogether we have 5 yogurts in our refrigerator. We also have 2 green apples and 3 red apples, so we also have 5 apples in our refrigerator. Part A asks, if he reaches into the refrigerator to get a yogurt without looking, what is the probability that Lucas will choose a raspberry yogurt? Well, we know altogether that we have 3 plus 1 plus 1. Altogether, we have 5 yogurts, and the chances of pulling a raspberry are 3. He can choose 3 of them. So your chances of pulling a raspberry yogurt are 3/5. Part B says, what is the probability that he'll choose a red apple if it is the first item he selects? Got to do the same thing. We look at all of our apples, and together we have 5 apples, so our total is 5. That is our whole. But his chances of getting a red apple, we only have 3. So his probability would, again, be 3/5. Part C gets a little bit more challenging where we're going to take two probabilities and multiply them together, and I'm using my table up here. So part C says, what is the probability that Lucas will eat a raspberry yogurt and a red apple? So since raspberry yogurt and vanilla yogurt and peach, since I don't have the same amount, what I need to do is take that into consideration when I'm making my table. So down here, I made my table of raspberry yogurt, vanilla yogurt, and peach, but I wanted to show that I have 3/5 here, so I put the fraction next to the raspberry. I also put vanilla yogurt as 1/5, and I put peach as 1/5 as well. Then my red apple I'll put down here as 3/5, and my green apple I put as 2/5. So when I find the combinations of raspberry yogurt with a red apple, I'm also going to multiply. That's a multiplication sign. I'm going to multiply my fractions. So that means I'm going to multiply, let's see if I need a pen. I'm going to multiply 3/5 times 3/5, which will give me 9/25. That's my chances of getting a raspberry yogurt with a red apple. I'm going to do that for the rest of them. A raspberry yogurt with a green apple is going to be 3/5 times 2/5, which gives me 15/25. And for this, I believe it was just asking what is the probability that Lucas will eat a raspberry yogurt with a red apple. That's this box right here, so 9/25 is going to be your answer. I hope this helped. I'll be back with more. See ya. 71 about probability. This has to do with the probability tree. And this was also on your math quiz, so it's a good time to review. This problem had to do with Marcus and his brother, and they had an argument about who was going to walk the dog. And so Marcus's dad came up with the idea that each boy will get a bag. They will get 3 blocks in there, a yellow block, a green block, and a white block. So I'm going to write that down. Yellow, green, and white. And each boy every night is going to bring their bags to the dinner table, and one boy will pull one block and the other boy will pull the other block. And if they have matching blocks, then Marcus has to walk the dog. If they don't, then his brother walks the dog. So we're going to try to figure out how many combinations are there total out of all the blocks, and we're going to try to figure out if this is a fair game, if they have equal chances. So we're going to start off with a probability tree. And what I'm going to do is I'm going to make a probability tree for Marcus. So Marcus has 3 blocks, so this is all representing Marcus. Marcus has 3 blocks in his bag. He has yellow, he has green, and he has white. Okay. Now we're going to extend our probability tree, and we're going to show the blocks that his brother has. So his brother is going to be in black. His brother also has yellow, green, and white. So every time that Marcus pulls green, his brother has the opportunity to either pull yellow, he might pull green, or he might pull white. If Marcus pulls white, his brother may pull yellow, he may pull green, or he may pull white. So part A asks to figure out how many possibilities are there. So this is a possibility of yellow and yellow, yellow and green, yellow and white, and so forth. So we can count up all of our possibilities over here, and we count up that as 3, 4, 5, 6, 7, 8, 9. He has 9 possibilities. All right. For problem B, it asks, what is the probability that the boys will draw matching blocks? And is this game fair? So in this section, we need to figure out where do we have matching colors. Yellow and yellow, green and green, white and white. So I'm going to grab another pen. And here we go. So matching right here is yellow. That is 1. Green and green is matching. And white is matching. So out of our 9 possibilities, we have 3 possibilities that they are matching. That's 1/3. And this game is not fair. It is not even. If it was even, it would be 50% or 1/2. Anyway, that's problem 71. I hope that helped a little bit more, and I'll be coming back to you with more problems.